Hello dear students. This video record is in the order the third one about assembly modeling. I think you remember previous video record. Finally, after having the models of two L-shaped prismatic components in assembly environment and mating them with respect to each other, said that have a break. After such a break time, then say continue on the rest. Yes. I open Inventor, and in the scenario said that in using classroom computers, you shut down the computer before leaving the classroom. So when you turn back and open the computer, since the data files deleted by the system automatically, those are normally saved in partition C, and you have no right to keep any data in partition C. When you open Inventor, you're going to find Inventor to its default configuration. Or if you are the administrator of your system, then of course, after opening the software again to continue on the rest, then the already defined project will be the selected project. Still, you make it inactive. To be able to make an active project inactive, default option in this list is to be selected. Classroom computer, you open software and you find Inventor with this selection. Now start from here. Say that you need to reactivate a project to continue or to have a look at, whatever the case is. Now answer the question how a project can be activated. Using the classroom computers, this is the way to follow in answering this question. First, click on Projects tab along Get Started ribbon. Okay, in the dialog box, select Browse tab at the bottom edge of the dialog box. And then in this search dialog box, show the address of the project folder. I know where it is. It is, if it is classroom computer, it is to be in partition D, Mac 114 folder. Yes. Previous video record, I already created the project folder within such a nested one. Yes, and it is project folder is over here, and open the project folder, double clicking, and thanks to project definition, you find the project definition file in the list. To be able to reactivate a project, say this method always is applicable, not a matter you are the administrator of your computer or a restricted user. Always it works. Okay, open the project folder when clicked on Projects tab, and then in the dialog box clicked on Browse button, and in the search dialog box it will appear in the screen after clicking on Browse tab. Show the address of the project folder, and over there select the project definition file with a click and then say open. That is it. Then you see in the first pane of this dialog, the name of the project is in the list and it is the selected one. This means it is the active project. Clicked on Done button. And then, okay, continue. I'm going to open the already created assembly file. Shall I indicate the address? No, just thanks to project definition stage. Since we already defined the work as a project, when I clicked on open button, then can see the folder as automatically selected, and in this pane the list of the already created files. Well, this is the assembly file. Open it and then clicked on this button. Yes. Now here, continue on the rest. I have the components correctly positioned with respect to each other, and then, well, the rest. In this example, this prism and the other prism are to be connected to each other using bolt nut fastener. Well, such a joint requires coaxial holes created within this and within the other. In real life, very similarly, operator just position the components with respect to each other and then start the drilling process. And in real life, the drilling process is applied in continuation. First, for this component, the hole is created via cutting the material within this component, and then continue and create the coaxial hole within the other. But in virtual environment, the holes are to be created step by step. By the way, as I already mentioned, I'm going to demonstrate the things after this stage, after having the components as positioned with respect to each other correctly, following two different ways. First way, I'm going to say long way, the other way, shorter one, short way. First, you're going to see in this video record, this part, you're going to see the things along the long way. Well, select this component or the other component. It's not so important. Select one of them with a click and then right click the mouse. If you say open after right clicking, select this option, then this means you isolated that selected component. Thereafter, you find the component in parts creation environment. Be aware. Close this file. But if you say not open after right clicking but select edit option, then without leaving assembly environment, this means you selected that one. It is as if in part creation environment. Well, the advantage of using this technique is that you see, well, the other component are in or the components are in the screen, but they are not active. This light tone implies that this component is not active. The active component is this one, and the active component, the selected component, will be, although it is still the assembly environment, while the active component will be as if it were in part creation environment. Along the ribbons can find the part creation tools. Okay. And then, well, as if in part environment, I'm going to apply hole creation process. Okay. Clicked on this button. It is the hole creation tool of the software, you know. And then, well, the hole is to house a standard bolt. So I'm going to teach the software that hole is a standard hole. You know how. In the dialog box, clicked on this button. Inventor understood that it is the case and hole is a standard hole, and the dialog box is greater in size and to its content broader. Well, at fasteners part, select the first the standard. You're going to use the fastener. It has been defined and manufactured in accordance with the definition of which association? Here is the question. And the answer, you know, unless otherwise mentioned, is ISO, International Standard. Select ISO option. Okay, and then from the other list, select the type of the bolt, or might be the case cap screw. Okay, and then select it. Hexagonal head cap screw. In this example, the bolt will be hexagonal head type bolt. Select this option. And then the other list is to select the diameter of the threaded part of bolt or cap screw. Well, you know, in the content of the course, it is a complementary chapter and its title is Threaded Features. While studying on that chapter, I'm going to provide the complementary things in detail about fasteners, about threaded objects. But here just this studying is to demonstrate how a bolt nut joint can be created, and one more time to demonstrate how a standard hole is defined. Okay, from this list, select the diameter of the bolt. Say, I'm going to, in this example, use the bolt, assume designer solve the design equation and determine the size of the bolt, in which size, in that size, it is going to be safe and strong enough, is 10. Okay, diameter is 10. Okay. Fitting type, this means the clearance between the hole and the body of the bolt, stem of the bolt, whether it is a normal fit clearance or close running fit or loose running fit. Depending on the case, well, you see the standard size of the hole changes. If it is loose running fit, means the clearance is at the highest level between the stem of the bolt and the hole. Okay, it is the hole to house the bolt. If we select normal, then you see diameter of the hole decreases to 11. Say that in our example, it is to be a normal fit, normal clearance. Hole is to be created truly, so true all option from this list is the correct option. Okay, and then the rest. Indicate the starting surface with a click. Okay, and then locate the hole with respect to two references. Surface is two-dimensional, you know, so two coordinates are needed. Clicked on this edge of the surface as the reference and say that distance from this edge to the center of the hole, the axis of the hole is 10 or 15, let's say 15. Okay, and indicate this edge of the surface as the other reference, and from here to the axis distance, let's say, is the same 15 millimeters. Okay, and then clicked on OK button. Since there is no more hole to create, instead of clicking on add and continue button, then clicked on OK button. Yes, created the necessary hole within this part of the first component. Okay, after finishing the things in edit mode, to finish the editing stage, don't forget, this is important, along the 3D model ribbon, find the last panel. It is the returning panel. Clicked on return button. If you forgot to click on return button, then following stages you may receive a notice and or error message. This is important. Don't forget to click at the end of editing stage. Don't forget to click on return button. Now you see, well, we turn back to normal assembly environment. How about the other component? The whole of the other component must be in alignment with this whole, the whole of the first component. The whole holes are to be coaxial holes because both of them will be the house for inserting a bolt. Okay, so take an editing right for the second component, left click, right click and edit. And now this is active, the other one is inactive. Well, draw your attention at the browser. If you selected a component for editing purpose, well, the part of the browser, it corresponds to the icons of the component, okay, you selected it for editing, will be in such a light background, okay, but the inactive part, for the inactive one or inactive ones, the component or components not selected for editing, okay, the background color of the region along at the browser will be in a dark tone. Well, this part is the part of the browser. It corresponds to the selected component, to its process icons. Okay, yes. And then, well, do not apply in my method the whole creation process. Easier method is that instead of trying to create the whole, calling the memory on the location dimensions and the size and type values, just to have the whole within this one as coaxial oriented and in the same size, yes, use this technique, cutting technique, extrusion. Take a sketch right over the surface, left click, right click, and say new sketch. And then to be able to have the necessary circle to bound the region, thereafter to apply extrusion process in alignment with the edge of the existing hole within the first component, apply project geometry process. Okay, and then yes, if you want, you may clearly see, indicate the edge of the available hole, this edge or the other edge, not a matter. Yes, indicating the edge of the existing hole, you see I managed to obtain its projection over the selected sketch surface. Finish the sketching stage, and now over the surface I have the projection of the edge of the hole, already created hole. It is within the first component, and now this area is the profile. In the correct size and at the correct place, apply extrusion process. Okay, in cutting mode, select cutting mode and truly cutting, select true all option, and then say OK. That is it. Now the holes are in alignment. Don't forget to click on return button. Yes, you see the holes are in alignment, and we are ready to insert the bolt. Don't forget to save the file, okay, after each valuable stage. Click on save button. System asking me there are some up-to-date things, then shall I save the model to its up-to-date form? Yes, click on yes to all and then say OK. And then, where are the fasteners? Okay. Using bolt nut type joints, using bolts and nuts to connect the components to each other, to be able to decrease the surface pressure, okay, between the head of the bolt or head of the cap screw and the surface of the component, and also to be able to prevent having possible damages, scribings over the surface of workpiece, we use intermediate machine elements where between the surface of the component and the head of the bolt, or between the surface of the nut and the surface of the component. Such an intermediate element, it is for increasing the surface contact area via which to decrease surface pressure and also to prevent the damages over the surface while the screw is bolt or cap screw is screwed tightly, is called washer. Okay, in English we say washer. Okay, write the word using text technique. Annotate, say that, write the note, general note. Just instead of using a blank page to write the words, I'm going to use it. Say the name of the machine element is washer. Washer. Yes, washer. In Turkish, our technicians say not washer, but they say rondela. Okay then. Well, see the name of the machine element in Turkish. To be able to open the same text box, general note box, yes, I found annotation folder. Clicking on the cross, drop the list, and in the list, this icon corresponds to this note. Right click the mouse and say edit. And then write the word in Turkish. This is in English. Okay, in Turkish, rondela. Or craftsman, preferably say pull. This is in Turkish. Yes, by the way. And then of course I'm going to delete this annotation. See how? Right click and select delete. Okay, continue. Washer is a standard machine element. Bolt is standard, not as well. So well, in the library of Inventor, you know, we have almost all of the standard machine elements. These are commonly used in industry. Okay, as parametrically available. The total number of standard machine elements, those can be found in the library of Inventor, is in the order of more than 800,000. How we can access to the library? Bring the cursor to component panel, find this multi-optional button and select from the list not place option. You know, place option is the correct option to select, to invoke, to call the model of non-standard components from the memory to the assembly environment. But if the component is a standard component and therefore it is to be invoked from the library, select the second option, place from content center. Content center is the name of the library of Inventor. With a click, start the invoking stage. Well, this is the dialog box. In the dialog box, what we have, two panes. Okay, along the first pane we have a list. Depending on the type of the standard machine element, select the correct folder from the list. Say in our case it is a fastener, so select fasteners book. It is library in the analogy. Yes, this is just the library environment, and in the library, well, select the book first. Okay, select the shelf. This is the part of the library. We have some shelves. Okay, over the shelves we have different books. Okay, from the fastener shelf, find the books folder. Well, first, okay, invoke the washers or thereafter. Order is not so important. We need to use one bolt, one nut, and two washers at both of the sides. Select bolts, book. It is in form of a folder. Double clicking, open that book, and then find the subfolders. These are just like chapters. Which kind of bolt? In creating the hose, we already decided to use hexagonal head type bolt. So hexagonal head type folder is the correct folder to select with a double click. Then after opening the book, you can find the chapter of the book. You can find such options in the larger pane. Well, each one corresponds to a certain standard bolt designed and manufactured in accordance with the rules of a certain standardization association. At this point, if you know the code of the standard, okay, the document published by the association, so to be able to find the correct option from such a long list much more easily, you can use this search facility. Write the code of the standard and then can find the correct option in the list. But if you do not know the code, but if you sure that you're going to use the one it has been designed and manufactured in accordance with which standardization association, then scroll the list and then find the acronym of the association. Well, I'm going to use the BOLT. Okay, it has been designed and shaped in accordance with ISO, and the code of the document I selected here is 4014. Okay, and then say OK. After indicating that you're going to use such a bolt, then the following one will be just the size selection dialog. In this dialog, well, first focus your attention to this part, as custom, as standard. If you select as custom, as standard option, then well, it is going to be defined as standard, and when you thereafter, after having it as model in the environment, when you attempt to modify it, for instance, say that cut a certain part of the object, then you receive error message. System will say that it is standard component, you cannot edit it. If you're going to edit it for some reason, for instance, well, the length of the bolt little bit longer than the reasonable correct order, so you decided to cut the unnecessarily extended part of the bolt. It is a kind of editing. If you're going to make such an editing, then in this dialog box, select as custom option. If you select as custom option, then Inventor will create the copy of the file in the project folder, and that file can be used for having the modified form of the object, the machine element. Well, in this example, no need to edit it, so I'm going to say as standard option. Okay. But here let me open a parenthesis and then make a highlighting. Assume that you're going to edit the bolt after having it as model. So you selected as custom option. And then since we selected as custom option, then software will ask whether we agree that the copy of the file in which we are going to have the model of such a machine element is to be saved in the project folder. Well, first select the size and then deal with the rest. See that stage. I remember created the holes to say that for 10 millimeters bolt. Here, by the way, the letter it precedes the number capital M implies that the thread profile, thread profile is isometric thread profile. As I said, later talking about the content of one of the chapters, it is about the threaded parts, threaded features. I'm going to deeply talk about such things, but M stands to say thread form, thread profile is as it is defined in the document published by ISO thread form. The number 10 is the diameter of the threaded part, measured diameter of the threaded portion. Okay. Here in the long way, well, this is a question, yeah, to deal. Okay, we said that diameter of the bolt is 10, but in the other list, you see we have the length of the standard bolts. Saying length of standard, nominal length of a bolt, we mean length of the stem. The thickness of the head is not included. Well, what should be the value? How many millimeters? In the market, the minimum length is 45. Okay, maximum length is 100 millimeters. Now, first here, since I forgot to measure the distance from here to there, or I do not remember in time, I forgot the thickness of this prismatic part. For a while, cancel this invoking process, clicking on cancel button. Okay, and then using the inspection tool of the software, take a digital ruler and then indicate this age. Yes, the thickness of this part 8 millimeters, thickness of the other part 8 millimeters. Okay, this means the length of the bolt should be sufficiently long, okay, to extend through both of the holes, and for having the further extended part beyond the surface of this component to use for screwing the nut. Well, onto the total thickness of the components, we need to add the thickness of bolt, thickness of nut, and also thickness of washers. Now here I am going to open my presentation. Actually, I'm going to deeply project the slides of this presentation followingly, talking about threaded parts, but say finding the slides in that presentation, I want to inform you on a certain agreement, common value. First, find the presentation, threaded parts, ST. Yes, threaded parts folder is here, and my presentation, screws. Okay, fasteners, and then quickly find this slide. It is about the thickness of nuts. By the way, in this slide you can see isometric thread profile. Yes, this slide can see if the profile, when we cut the threaded part at the symmetric cross section, is like this one, then we say isometric thread profile. ISO thread profile. Yes, isometric thread profile. These are all standard values. Okay, it's a long yes, here. If we use style style 1 type nuts, then the thickness of nut you see is approximately the diameter of equal to the diameter of the threaded part of bolt. Well, round this number to 1 and say that it is almost equal to the diameter. D is the diameter of the threaded part, okay, of the bolt. So, well, since in our example the diameter of the threaded part of the bolt is 10, round this coefficient to 1, say that the thickness of the nut is 10. How about thickness of washers? Well, find the part of my presentation. It is about washers. Yes, washers. And then a table. It says bolt size 10. Nominal value for the washers is bolt size. Okay. And then this is British, American series. This is metric series, bolt size 10. Okay, follow this row, this one, and then flat washer, say that we're gonna use flat washer, thickness of the washer. If the bolt size is 10, then from the table see that it is 2.5 millimeters. Round it to 3 millimeters. At both of the sides we're going to use 3 washers, so 3 plus 3 6 millimeters is needed to consider in determining the total length of the stem of a bolt. Okay. And also it's a good practice to have when we tightly screw the bolt against the nut, beyond the surface of the nut there should be few more millimeters extensions. Okay, so well, I'm going to consider all of such things in making the selection. Okay, well, thickness of the part, this and the other, 8 millimeters, 8 plus 8, 16 millimeters. We need to consider the thickness of the nut because through the hole of the nut the stem is to extend. It is 10, almost 10. 16 plus 10, 26. Okay. This side there will be a washer. Its thickness is 3 millimeters, near to 3 millimeters. I said 8, 8, 16 plus 10, 26 plus 3, 29. One more 3, 32. Okay. And 3 more millimeters further extension is a good practice at least. So 25. Am I true? 16, 36. Okay. Oh, sorry. 16 millimeters is the thickness plus 10, 16, 26. Almost say that 10 more millimeters, 46 millimeters. So well, in the market the minimum length of a bolt, its diameter is 10, is, as I remember, 45. This means the bolt to its minimum length going to be sufficient for our example. But here in the long way, that's why I say long way, it is one of the reasons. You see, you need to make such shopkeeper calculations. Call the memory on the thickness of nut and then consider the thickness of washers and add them up, etc. But in the shorter way, no need to make such calculations. You're going to see later how. Okay, then turn back to assembly environment and then from the content center, I said that select this one, ISO 4014, and then say OK. And in this dialog box, assume that, well, later after having the bolt and finding its length is not so good, well, we may need to cut its end, trim it. So if it is going to be such an editing, then select as custom option. Well, here, although, well, I'm not going to edit it after having the model of the bolt, but I want to indicate something. So assume that as if it is gonna be necessary to edit the standard components. So have it as copy in the project folder. If you select as custom option, then it is the copy of the file in which we have Inventor keeps the creates and keeps the model of the component will be created in project folder. Okay, diameter of the bolt is 10, and if I am not wrong, my calculation is correct, then 45 millimeters is the necessary length for the stem. Select this one and then say OK. Yes, since I selected not as custom, not as standard, but as custom option, Inventor right now asking my verification whether I'm going to save the copy of the file in which the solid model of the bolt will be available within the project folder. This is the content of the project folder in the dialog. Here, this is important. You know, in my courses at the saving stage, I said that write the file name, first writing your surname, ID number, etc. But here, if it is the saving for the file to have in the file the model of the standard component, do not change the file name, because this file name actually is the technical node to write within parts list where on an assembly drawing as the technical node, specification node. If you change the name of this file here, then the technical node at the parts list along the nodes column will be wrong. Okay? Only for standard components at this file saving stage, do not change the file name. Keep it. It is just the necessary technical node in form of the specification node for that standard component to write and to find at the parts list of assembly drawing. This is important. Do not change the file name. Just click on Save button. And that is it. Now this is the simulation. In the vicinity of the existing part of the assembly, located arbitrarily first. Okay? And then, well, if you need to use more than one bolts in the same shape and size, then continue to make the clicks. Click, click, click. But if it is only one, then press Escape button. Yes. How about the other components? But I see here the length of the stem is, well, longer than the necessary order. 16, 26, yes, not, I said 36. 26 plus 10, 36. But the length of this one is 45. There will be unnecessarily further extended part. So, well, I'm going to delete this bolt. I'm going to try the other standard bolts. Well, this is too long. It is gonna be waste of material and also waste of energy if we cut the material in real life. If you, for instance, from the market purchase, select such a unnecessarily long bolt, then to be able to trim it, you're going to use energy for cutting the further unnecessarily extended part. So, well, see also in such a case how a solid model can be deleted, okay, if you gave up from using it. Gave up from using. Bring the cursor to the browser. This icon corresponds to that standard component, and right click the mouse and then say delete. Or not delete, but change its size, change its type. So from the list, select repeat place from content center, no. Change size, if the type is correct but the size is wrong, select change size option. Yes, then if you say change size, then you find the size selection dialog box again. But it is not our case. Not the size, but the type is to be changed. Okay, so select replace from content center option, or completely delete it, and then in the library select it again. But this is, I think, is shorter to follow. What did I do? I selected the icon with a click, right click, and then instead of deleting and opening the library again from the beginning, I said that replace it from content center, replace it with a different one. I selected replaced option. Okay. And here, for ISO 4014 type bolt, couldn't find the length of the bolt less than 45. Well, in my application, in our case, the length of the stem totally is to be 16 plus 10, 26 plus 10 more, 36 millimeters in this order. It is enough, not 45. So I'll try to use the other one, for instance, ISO 4015. Check whether for this type the length of stem is less than 45. And then say OK. And in the selection dialog box, you see, well, metric 10, not 45, but it is 40. This is better than the previous one. How about ISO 4016? Select metric 10. No, 45. This is not so suitable. 4017. Select 10 millimeters. Yes, here, great. If the bolt is the one, it has been shaped and sized and manufactured in accordance with the things written in document 4017. Yes, for 10 millimeters bolt, minimum length of the stem is 20. If say in my calculation the necessary order for the length of the stem is 35, so I selected 35. Okay, and since no need to cut the stem because it would be otherwise further unnecessary extended part, say I'm going to select not as custom option but as standard option, and then say OK. Yes. And now it is shorter in length. Okay, then, well, re-clicked on the library option, place from content center option. In this case, from the fasteners book, select nut option, nut folder. Well, hexagonal head bolt normally used together with hexagonal type nut, so I selected hexagonal type. It is to be in accordance with ISO. It is thread form, must be ISO thread form because we selected the bolt in accordance with ISO. So from the list, find ISO options. Well, we have different bolt types, say nut types. Well, which one? I'm going to use ISO 4032. I selected this one and then say OK. And this is the size selection dialog box. Bolt is 10 millimeters bolt, so nut must be in the same size. Metric 10 is the thread size, measure diameter of the threaded part. It must be the same. No need to edit or modify nut, so do not select as custom option, as standard option. And then locate the nut in the vicinity arbitrarily with a click. Press escape button. And then washers from the library. Clicked on this button and then fasteners shall select washers folder. Which kind of washer? Well, gonna use plain washer. Yes, plain washer in accordance with ISO 70 90 70 90 70 90. I selected this type of washer, this standard. It is about a certain type of washer. And then, well, the nominal diameter of washer is the bolt size. It is the washer together with use with a standard bolt, and the size of the bolt is 10. Okay, no need to modify washer via cutting, etc. So select as standard option and then say OK. Click one more time. Click. Why? Because we're gonna use 2 washers. Press escape button and then the rest. Mating stage. Clicked on constraint button and in the dialog box. As I briefly inform you, in the previous video record, if for the components, these are to be positioned with respect to each other, longitudinal axes are defined, and the in positioning the axes are to be in alignment as coincided to their line of actions onto each other, then select this mating option, insert option. Okay, and then it is to say that, bring the cursor to the edge of this hole. Okay, if the cursor is sufficiently close, and if you selected insert option, of course, then start seeing such a highlighting. The highlighted one is the edge of the hole and the axis, line of action of the longitudinal axis of the hole. Well, if your purpose is to position the component, okay, in alignment with the axis of the hole, then yes, make a click. And then bring the cursor to the edge of the washer, this side, and then indicate it. And then say apply. Yes, then the washer, indicated washer, will be positioned at its correct place. Continue. And then after positioning the washer in the order, insert the bolt. The edge of this edge of the washer, this is the same type option, and yes, the edge of the root of the stem, indicate this one, ought to be in contact. So I indicated the edge of the washer and edge of the head of the bolt, or edge of the root of the stem. Now this is a correct positioning. By the way, if you find the component like this at the wrong side, okay, unrealistically embedded within the object, then yes, like this is unrealistic. You see, the head is now within the prismatic component. This is the wrong orientation, so flip-flop. Try this solution. Now this is correct. Okay, and then say apply. Continue. Now indicate the edge of the other hole at this side, to say that edge of that hole and the edge of this washer indicate the edge at this side. Okay, to say that these are to be in contact, and then check whether the washer is at the correct side. Not like this, but like that. Yes, now washer is at the correct side, not within the prism as embedded unrealistically. If you found the component at the wrong side or unrealistically as inserted, embedded into the other component, then change the solution, this or that. And then yes, this is correct positioning. So if you're sure that the thing is correctly positioned, click on apply. And then finally, okay, indicate the edge of the washer, to say that this edge of the washer and that edge of the bolt going to be in contact. Yes, it is okay. If you couldn't find the nut at the correct side, then change the solution, not this but that. But it is okay in my case, so click on apply button, and then clicking on cancel shoot this dialog box. Yes, this is the end of this video record. In this video record, I inform you how a standard component is invoked to the assembly environment, and then how it is positioned at its correct place. But you watch the film, you saw such things, along the long way. The long way, first it is necessary to create the standard tools one by one, you know how. Okay, and then from the library invoke each component and then be able to make them using this type option insert. Okay, if for the components and the feature to relate with the components, standard components, longitudinal axes are defined and the components are to be in alignment along their longitudinal axis. Okay, thank you for your watching. Stay healthy. Next video film, I'm going to video record. I am going to reach to the same end, starting from the beginning of the stage, saying that shorter way, easier way to have the same joint in the end. You're going to see how. Bye bye.